Do you know, nearly 3/4 of the Earth's surface is covered by water, and virtually all of it is salty in the seas and oceans. Less than 1% is actually fresh water, but most of us are lucky enough to take water for granted. We enjoy its scenic qualities, and we use it largely without thought. We wash in it, cook with it, and drink it in many forms, apart from which, another fact, water represents nearly 2/3 of the human body weight. Water is also... Most pharmacopoeia specify 2 main water qualities for use in the manufacture of pharmaceuticals and other healthcare products. First, purified water, and second, water for injection, commonly referred to as WFI. Precise specifications for water vary with regulatory jurisdiction and geographic market considerations, plus, of course, ideas change. This table illustrates the still widely used chemical specifications, which are the same for both pure. The top layer of a typical filter will be of a coarse and low-density material such as anthracite, then down through layers of silicas to the lowest level comprising the finest and heaviest media, usually a vitreous silicate called garnet. This type of filter can remove up to 98% of particles above 20 microns in size, and regular backwashing is required to remove this buildup. If the incoming feed water has low levels of suspended solids and water is required in relatively low volume at low flow rates, the right quality purified or WFI is of use only when it's available at the right place and in the right quantity. It must be stored and distributed, and these phases require considerable attention to detail because the microbial and chemical quality can easily deteriorate after the purification process. The system must ensure that purified water is never stagnant, is circulated in turbulent flow at internal pipe face velocities of between 1 to 3 meters, that's 3 to 10. Purified water systems are inevitably complicated, and water for injection systems, with their tougher microbiological requirements, even more so. From the moment feed water enters the system through its pre-treatment and purification processes, there are countless opportunities for breakdowns and failures. Systems should be designed to recognize this, to give maximum accessibility, and to ensure that routine monitoring and maintenance can be undertaken while subjecting the system as a whole to the minimum actual disturbance. System cleaning can be done using validation of the water system starts with system, subsystem, and component definition. Standard operating procedures should be created before the system becomes operational. The validation protocol should state clearly what must be done, anticipated results, and acceptance criteria. Routine monitoring must state alert and action levels. The maintenance logbook provides the history of the system.